Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll evaluate limits for absolute value functions. As per the prompt, evaluate the limits using one-sided limits. We have to evaluate these two limits. Let's start with the first one. Limit x approaches 2, x squared minus x minus 2 over absolute value of x minus 2. The first step is to factor the expression in the numerator. It is a simple trinomial. We can factor it using sum and product method. As per this method, we have to find two numbers whose sum is -1, the coefficient of the x term, and product equal to -2, the number term. The two numbers that satisfy these two requirements are -2 and 1. So we can write the factored form as now we can evaluate the limit. We cannot use the direct substitution method to evaluate this limit because of the absolute value function in this expression. So we have to use left hand limit and right hand limit to evaluate this limit, because that way we'll be able to get rid of the absolute value function in this expression. An absolute value function is a function that makes the value of every expression a positive value. For example, absolute value of 3 is 3 and absolute value of -3 is also 3. Let's start by analyzing the left hand limit. For left hand limit, we put a small negative sign on 2. For left hand limit, we approach 2 from the left side. So the expression absolute value of x minus 2 changes to negative x minus 2. Because as we approach 2 from the left side, the value of x will be less than 2. For example, 1.9. If I sub in x as 1.9 in the expression x minus 2, I get negative 0.1. Since the absolute value function always gives us a positive value, we assign a negative sign to the expression x minus 2, because negative minus 0.1 will be equal to positive 0.1. This is a very important concept we need to understand and memorize to solve this type of problem. Now we can simplify the expression. We can cancel out the x minus 2 from the numerator and denominator. Next, we can apply the limit. We should sub in x as 2. I get -3. This is the value of the left hand limit. Now we can evaluate the right hand limit. For right hand limit, we put a small plus sign on 2. For right hand limit, we approach 2 from the right side, so the value of x will be greater than 2. That's why we can change absolute value of x minus 2 to just x minus 2, because for x greater than 2, x minus 2 will have a positive value. There is a very important concept we need to understand and memorize. Now we can simplify this expression. We can cancel out the x minus 2's. Next, we can apply the limit. We can sub in x as 2. I get 3. This is the value of the right hand limit. So we can see that the left hand limit is not equal to the right hand limit. Therefore, we can conclude that the limit does not exist or DNE. This should be the final answer for the first limit. Now we can analyze the second limit. Limit x approaches -2 for x plus 2 cube over absolute value of x plus 2. We cannot simplify this expression. In order to evaluate the limit, we have to get rid of the absolute value function. For that, we should evaluate the left hand and right hand limits. Let's start with the left hand limit. For left hand limit, we should put a small negative sign on -2. For left hand limit, we approach -2 from the left side, so the value of x will be less than -2. Since the absolute value function always gives us a positive value for an expression, if we sub in x as a value less than -2 in the expression x plus 2, like -2.1, I get -0.1. Since absolute value function should always return a positive value, we assign a negative sign to the expression x plus 2 for the left hand limit, because negative 0.1 will become equal to positive 0.1. So in the denominator, we write the expression negative x plus 2. This is a very important concept we need to understand and memorize. Now we can simplify this expression. We can cancel out an x plus 2 from the numerator and denominator. Now we can apply the limit. We should sub in x as -2. -2 plus 2 is equal to 0. I get 0. So the left hand limit is equal to 0. Now we can evaluate the right hand limit. For right hand limit, we should put a small plus sign on -2. For the right hand limit, we approach -2 from the right side, so the value of x will be greater than -2. If we sub in a value greater than -2 in the expression x plus 2, like -1.9, I get 0.1, which is a positive value. Since an absolute value function always gives us a positive value for an expression, we can change absolute value of x plus 2 to just x plus 2 for the right hand limit. There is a very important concept we need to understand and memorize. Now we can simplify this expression. We can cancel out an x plus 2 from the numerator and denominator. Now we can apply the limit. We should sub in x as -2. I get 0. So the value of the right hand limit is equal to 0. Since the value of the left hand limit is equal to the value of the right hand limit, that means the limit exists and the value of the limit is 0. So we can write our final answer as the value of the limit is 0. This should be the final answer for the second limit. So these are the steps you have to keep in mind to solve limits like these. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.